This is the second page for 9.2. We're going to write equations when we're given part of our parabola. We know that the directrix is y equals 2. So if we make a sketch and y equals 2 is our directrix, then we know that our focus point is down 2. So we know that our p value is going to be -2. The graph is going to have to open up downwards, so we know that it is an x squared type equation. X squared equals 4py. So our equation is x squared equals -8y. If our directrix is x equals 4, then we know that the focus point is p equals -4. It opens up sideways, so we know it's a y squared. 4 times px. So we're going to get y squared equals -16y. For this problem, we know what the focus is. The focus is -2. So we know the directrix happens to be +2, but not overly necessary to know that to write the equation. We just need to know that the p value is -2. It looks like it's going to open up sideways again. So 4 times px. So our equation is y squared equals -8x. The focus is 0 right and left, but 3 up. So the directrix would be 3 down. So I know my p value is +3. Because the focus goes upwards, I know that it has to be an x squared, and it's 4 times the py. So x squared equals 12y. If you look at the picture, for example number 4, we see we have the y-axis, so our vertex is right on the y-axis. We have a focus, which gives us a p value of -3. This is our directrix of x equals 3. So since it's opening up sideways, we know it's going to be y squared 4px. So y squared, if p is -3, then we know the equation is going to be y squared equals -12x. Working on example number 5, the story problem. We have parabolic reflectors have cross sections that are parabolas. Incoming sound, light or energy that arrives at a parabolic reflector is parallel to the axis of symmetry and is directed to the focus. Similarly, energy that is emitted from the focus of a parabolic reflector, and then it strikes the reflector and is parallel to the axis of symmetry. So we're going to take this flashlight and we're going to use the mirror and our light source, which is inside. We're going to write an equation for the mirror's cross-section, and then we're going to determine how deep it is. So here we have this flashlight. Okay, and this is your reflection. We know that the flashlight is 4 inches wide. The light bulb is a 1/2 inch up, so that's going to represent our focus. So we know that the p-value equals a half. We see that the parabola opens upwards, so we know it's an x squared equals 4py in standard form. So x squared equals 4, the p is a half, y. X squared equals 2y is the equation of this parabola. Now, for us to figure out how deep it is, that's the depth. Okay, we're going to come out a total amount of 2 inches. This would be our axis of symmetry. We're half an inch up. We're 2 inches to the side for us to reach that maximum amount. So we're going to plug a 2 in for our x. So when we plug 2 in for the x, it looks like we're going to get 2 for the y. So we get the mirror is going to be 2 inches deep. We plugged a 2, which was the distance to the side that reached our maximum value, and we could figure out what that maximum value was, and that was 2 inches. When x was 2, y happened to be 2 also.